It's a very good evening and a very good evening to online students too. Please switch on your cameras. Reveal your faces with a little smile too. Yes, please write a few thoughts, then we'll start. Adapt or perish, now as ever, is nature's inexorable imperative. Means today and as it has always been, the only way to survive in this world is adapt or means either you need to adapt or otherwise you'll perish. This has been the rule always. And for this examination also, the success rule is that keep adapting to the requirements of this examination. Okay. Keep evolving every day for this examination. Don't compete with anyone in life. Compete with your own self every day. No, keep improving yourself and you will see first attempt would be the last attempt. No. This is about our nature. Anything which is there in the nature is never ever disgraceful. Means whatever Mother Nature has provided. Yes. Yes, it's for revision sake. Revision in UPSC is very important. No? Don't worry, I'll give you 3 or 4 new ones also. No. Next one. In the practice of tolerance, one's enemy is the best teacher. Means nothing great if you are tolerant towards people at home. You need to learn to be tolerant with people whom you hate otherwise. That is true tolerance. Good for paper on ethics and essay writing. Next is also good for essay writing. Mobs have passions, not brains. There's a Latin proverb. We are the authors of our own disasters. Now, when you will do your ecology classes, you will get to know from the teacher and otherwise from general awareness that most of the so-called natural disasters these days are anthropogenic in nature. So there's a Latin proverb saying the same, we are the authors of our own disasters. And I believe it is true for even social life. No, we do social disasters in social life for our own reasons. Don't worry in life. Worrying is like a rocking chair. It gives you something to do, but gets you nowhere. The last one is success is not the result of spontaneous combustion. You must set yourself on fire. Don't take this statement in literal sense and then blame the teacher there. This is to be understood philosophically, that sudden impulses of motivation will not pass through this exam. You need a long disciplined routine of hard work for success in this examination. So work hard in your first attempt so that you don't have to take number of attempts in Delhi. You'll be working much more if you have to go for many attempts. Okay, fine. No perversion after this. But some people are looking at me, why doesn't he teach geography only? I'll come to my business now. Let's have geography. Is it over? Sorted? Fourth one, what? Not understood. Means what exactly one? Fourth one, what? What is that? Thought? 1, 2, 3, 4. Mobs have passions, not brains. Now, before I go for the lecture today, there is a student, Amit Maurya, writing that if latitude lines are horizontal, then how it is angular distance, means how it is angular distance measured north or south. Remember, I never said parallel is a angular distance. It is latitude is the angular distance, right? So latitude is the angular measurement of a place, north or south of the equator, as we happen to see in the previous lectures. And parallel is a line joining places of the same latitude. Okay. So please do clearly distinguish. This is what we did not do in school. Latitude and longitudes are two angles, and parallels and meridians are two lines or sets of lines, and the network of those lines is what we call as grid system. Okay. Now, I believe that we have to start from the conversion of latitude into linear distance. No? So let me tell you the plan for this lecture. I've already explained that. I repeat. Now she is asking about the doubt which we happen to mention at the end of that discussion. See, there's a mathematical property of great circle that for any 2 points on the surface of a sphere, the shortest distance will always lie along the arc of the great circle joining those 2 points. And this statement is valid for any 2 points on the surface of a sphere. So if there are 2 points on a particular parallel, even other than the equator, then you can always join those 2 points by the arc of a great circle. And that arc will give you the shortest route. So I said, if this is my earth, and I take any parallel here, and there are 2 points on it, let's say C and D or A and B. Now, you know this parallel, let's say if it is 30 degrees north parallel, it is, you know, a circle on the globe, yes or no? And it's a small circle. So the first understanding is arc AB on the globe is not the arc of a great circle. So arc AB, since it is not the arc of a great circle, so it doesn't represent the shortest distance for A and B. This is good. But to say that for A and B, I cannot have the arc of a great circle, that is a wrong point. It means you need to understand that for even points like A and B, we can have the arc of a great circle. So imagine these 2 points A and B are on a ball and you have a knife with you. Can you run a knife through A and B and the center of the ball? Answer is yes. And that makes you understand that for A and B also we have the arc of a great circle giving you the shortest route. Is that okay? And then I give you a finer point that if this parallel is in northern hemisphere as taken here at this moment, the shortest route will always lie on the north of this parallel. And if there is a parallel in the southern hemisphere and there are 2 points here, C and D, for these 2 points, the arc of the great circle would lie on the south because of the earth being spherical in shape. Higher we go in latitudes, the earth becomes smaller in size. Okay. So the point is that statement that arcs of the great circles provide the shortest route is a valid statement for any 2 points of the earth's surface. Okay. Now, please write the title, Conversion of a degree of latitude and longitude into linear distance. It means we raise a simple question now that a degree of latitude and a degree of longitude would mean how many kilometers on our earth, on our planet. Okay. Now, how can we find out this? If I'm able to establish a relationship between the angular distance and the linear distance. Let's do it one by one for both latitude and longitude. So let's first convert 1 degree of latitude into linear distance. Means we ask this simple question that a degree of latitude would mean approximately how many kilometers on the earth's surface. Now we need to make a relationship between the latitudinal angle and linear distance. Now, just go the way I taught this topic last time. If you take my left hand, the way I'm holding it, as the equatorial plane of the earth. Equatorial plane, you understand? If my left hand is the globe, the imaginary plane which cuts the earth through the middle. So if my left hand is the equatorial plane, and if you take this as the center of the earth, and this as the point on the equatorial plane itself, now how many degrees a place is on the north of it, or how many degrees a place is on the south of it, that is called latitude. So let us make the angle called latitude from 0 to 90 degrees. So let's say this tip of the finger of right hand is the point P, which is given to me. If I put P over A, at this moment the latitude of P is 0 degree. Now I make an angle of 0 to 90 degrees. For this, I make my right hand move like this. So this is 0 and this is now 90 degrees north pole. Now when I make an angle of 90 degrees, just visualize that how much is the linear distance the point P had to move on the earth surface. No, I'll answer. See, this is not a question for you. This is for all classes. See, I have to keep myself motivated. This is my third lecture and I have to speak for 7.5, 8 hours. So, and to make my presentation structured, I'll keep raising the question myself. Okay. I know your questions. So I keep, and when I ask you, I'll ask you, you answer the question. Okay. I'll be very clear. This is with all means I understand that you are answering me. It's a good thing. But I'll answer. Means I mugged up the topic before the class. Okay. Left hand is equatorial plane. And this point is P. I make 90 degrees angle of latitude, 0 to 90 degrees. Here. Now to make this 90 degrees angle, how much is the linear movement of the point P on the earth surface? Now since I do not have the third hand, so I'll have to replace this. I'll say this much is the distance moved. Yes or no? Yes, please. And this is what someone was saying. It is 1/4 of the circumference of the earth, right? So it means I've got the relationship. 90 degrees of latitude equal 1/4 of the circumference of the earth. And circumference of a sphere is, yes please, 2 pi r, where r is the radius of the earth, and radius of the earth you can take approximately as 6,400 kilometers. So please find out the answer. If this is the relationship, everyone should find out fast. 1 degree of latitude would mean how many kilometers approximately? Very good. It is approximately 111 kilometers. Good. Everyone should get that answer. 1 degree of latitude is approximately 111 kilometers on the earth. Yes, is that okay for everyone? Yes, please. So this is how we convert latitudinal degrees into linear distances. So on an average for our classes now, a degree of latitude would mean 111 kilometers. Now, before I go to longitude, I make one final observation. Not so important, but somewhere you may find it and you should know it. Know this. Please see here. We noted in the previous lecture that Earth is bulging out of the middle portion, but it is flattened at the poles. Now, we have understood today that 1 degree of latitude is approximately 111 kilometers. But look at this point, that since Earth is flattened at the poles, so in the polar region near the pole, a degree of latitude would be slightly longer than a degree of latitude near the equator. Think of this point, that since the earth is flattened at the poles. Now, let's see it in a very crude way. If this is the North Pole, flattening means what? I press my skin on the top here. Can I say when I press my hand like this, the skin will get stretched? Means Earth's crust will get stretched. So because of this little flattening here, a degree of latitude gets little longer than what it is near the equator. There's not much of a difference, but as a concept you must know that since the earth is flattened at the pole, there is a slight increase in a degree of latitude in terms of linear distance. So write this point, please write. As earth is slightly flattened at the poles, as the earth is slightly flattened at the poles, put a comma, right? The linear distance of a degree of latitude, the linear distance of a degree of latitude at the pole, the linear distance of a degree of latitude at the pole is little longer than that at the equator. Is little longer than that at the equator. Now let's go for this conversion. Please write now 1 degree of longitude is approximately how many kilometers? Now for this, let me just make a rough diagram. Now let us suppose I draw one meridian here. Now I draw one more meridian, which is at a distance of 1 degree of longitude. So let's say this is one particular longitudinal value, and I draw one more meridian at a distance of 1 degree longitude. Now just look at the northern hemisphere. Can I say it is visible that 1 degree of longitude means if these two meridians are separated by 1 degree of longitude, can I say it's visible that a degree of longitude has maximum value in terms of linear distance at the equator? But as I go towards the poles, this distance or this value is decreasing. And at the north or south pole, it would be 0. So it means first means there could be many answers for 1 degree of longitude. So 1 degree of longitude at the equator. This is what I want to find out first. So how many kilometers would or should I say 1 degree of longitude would mean how many kilometers here? Means this distance is how much? I want to make this calculation. So I first need a relationship between the longitudinal distance and the linear distance. Now, can I say this circumference which is there, this is 2 pi r and this is equal to 360 degrees of longitude? Yes, please? Means remember 180 degrees and 180 degrees on the other side. So to find out this longitudinal distance, how many kilometers it is? So I say 360 degrees of longitude would equal, yes please, how much? 2 pi r. Yes please. And if you just see it, it is same as what we wrote for latitude. There we wrote 90 degrees of latitude is equal to 1/4 of 2 pi r. And now we are writing 360 degrees of longitude is equal to 2 pi r. So how much it would be? At the equator, 1 degree of longitude would be same as we have calculated for latitude in general. And that is approximately how much? 111 kilometers. Is that okay for everyone? That this 2 pi r is equal to 360 degrees of longitude. And that gives me 1 degree of longitude equal to 111 kilometers. So I have calculated 1 degree of longitude at the equator as approximately 111 kilometers. What is the second answer? What is the value at the pole? At the north pole or south pole, it is 0. Because all meridians will converge at the north or south pole. So there is no linear distance left at the poles. Now, these are the two important values for us, this 0 and 111 kilometers. The third value which I'll give you will not do carry calculation, that's not required. We just need to remember that value. See here. If the question in mind is that at what particular latitude, means this is 0 degree and this is 90 degrees. At what degree latitude, at what parallel, 1 degree of longitude would be approximately half of what it is at the equator. At the equator, it is approximately 111 kilometers. So if I want to know that on which parallel, on which latitude, a degree of longitude is approximately 56 kilometers. 56 is approximately half of 111 kilometers. So I want to find out at what parallel, at what latitude, a degree of longitude would become approximately half of what it is at the equator. Then what is the answer you expect? See, answer is not 45. 45 is the answer. I will not take 5 minutes to explain this, no? Means I would not mention it if it is 45 degrees. See, Earth is spherical in shape. So for this reason, that it is not 45 degrees answer. Because in the coming classes, we'll learn something important about this shape. Now, let's see whether you understand in today's lecture or not. We'll not use it, but it will be relevant for future classes. Keep your eyes on the board and think of this observation. I say, since Earth is spherical in shape, so as I go higher in latitudes, Earth gets smaller in size. Is that understood? Means this Earth is very large in the lower latitudes, whereas polar Earth is very small. Is that okay? So as I go higher in latitude, Earth is getting smaller. But the interesting point is that as I move from equator to the poles, the rate of decrease of the size of the Earth is not uniform. Means Earth is decreasing in size at a faster rate in higher latitudes. Means when you move your eyes from equator to this, let's say 15 degrees or 10 degrees north, there is a very small decrease in the size. Those who don't understand, it's like this. Now you understand very well, no? When I move my hands along the waist, it's almost cylindrical. There's hardly any change. This is like my earth. No, when I move my eyes here, there's a very slight change. I don't feel it. But when I move my eyes here, there's a sharp change. So in the coming days, we'll be using this property that since my earth is spherical in shape, so earth gets, think of this sentence, I say earth gets increasingly smaller in higher latitudes. Means it gets smaller in higher latitudes at a faster rate. In the lower latitudes, it's getting reduced in a gradual way. But here it is getting smaller in higher latitudes at a faster rate because of the spherical shape. So we'll not need to go into the calculation. We'll remember one point, that a degree of longitude is approximately 56 kilometers at approximately 60 degrees north and south, not at 45 degrees, okay? So 60 degrees north or 60 degrees south, the value is about 56 kilometers. So please write this as a factual information. We did not have calculations of this in geography. So write one more point. There are three observations, two you have written. So write the third one. Please write a degree of longitude is about 56 kilometers. A degree of longitude is about 56 kilometers. That is approximately half of what it is at the equator. That is approximately half of what it is at the equator. At 60 degrees north or south. At 60 degrees north or south. Is okay? These are the three observations we need to know for longitude. So we complete this conversion of latitude and longitude into linear distances. Now, let me take you to the next part of the discussion, which will be, remember, in today's lecture, I'll share with you one or two points which would be important for our future classes. Means details you'll understand later, but today we'll highlight those particular features. Now, those of you who have seen your NCERT books, or you may remember from school days, that when we talk about latitudinal division of the earth, remember we divided earth last time into 6 latitudinal regions. But you might have seen in the same kind of division, the books using the terms torrid zone, frigid zone, etc. So I want to use those terms in my lecture in this part of the discussion. But I want to do it with a little larger purpose for my future classes. Your school books will do with a limited approach, but for my future classes, I need something which I'll give a focus in this discussion. Now, before I start that particular discussion, I would share with you a few thoughts about the distinction between the term weather and climate. Remember, in the coming days, we'll be covering all technical elements of these two terms, no? But for some broad idea today, I'm going for a very broad perspective approach for making you understand these two terms. So don't worry about the details. Details will come when the right time comes. So let's go for a brief discussion on term weather and climate. So write this title and be on the board. Just write the title and give me a few minutes on the board. Now, and please don't write, listen to this. Can I say that both these terms relate to state of the atmosphere? Okay. Now, can I further say, based on your experiences of nature, that state of the atmosphere may be represented by many elements, but the two major elements which all of you will agree, or even the person on the road will agree, that state of the atmosphere is best represented by heat in the atmosphere. Yes, please. Even if I stand on the road and ask a common person, even he or she will say the same answer. Words may be different. A common man may use the word temperature for it, but idea would be the same. Can I say the second important thing which makes me understand the state of the atmosphere would be the moisture in the atmosphere? Yes, please. So with your experience of nature, you understand heat and moisture are the two major elements describing the state of the atmosphere, which we understand as weather or climate. Now, these two are known to even a common man on the road. But you will see in the coming days that what is important besides these two elements is that you should also understand that in our real nature, heat and moisture would travel from one place of the world to another. So means nature is what it is because of transfers of energy from one place to the other. And without those transfers, perhaps Earth would not have been a living planet. So I want my class to understand, though details are not there with you, but you will see it in the future classes, that the state of the atmosphere gets represented by heat and moisture and their motions. Means very important point of my classes with you will be that heat and moisture travel from one place of the world to another. And that is one major reason of Earth being a living planet the way it is today. In fact, I would make a statement, again, you will not make much understanding out of it today. I'm going to teach you atmosphere and world ocean. And I would say today that every major circulation of air and every major circulation of water in the world ocean would have one common pursuit, and that pursuit would be to transfer the energy from one place to another. Means all wind systems, which you have read and heard about in school, trade winds, westerlies, polar easterlies, cyclones, monsoons, whatever you have heard of, or whatever you have heard of in the oceans of the world, like ocean currents and all that, all have one common purpose in nature, and that is they are trying to transfer energy from one place to another. And without that transfer, Earth would not have been what it is today. So my whole course is about the movement of energy from one place to the other. So I want to highlight this point without details today, that what is my weather or climate? It is about heat and moisture and their motions. Now, there may be some students who may be not able to comprehend today that what exactly is the reason for movement here. I'll give one brief example here, and details of this would come in the future classes. Let's try to have an example for this movement part. You all know that India has monsoon type climate. By monsoon, we mean that there is a system of moisture laden winds which come to India for 4 months, June to September, from the same direction, southwest. So you might have heard of southwest monsoon during summer of India. And this monsoon is very important for India because this southwest monsoon, which is there over India for June to September, this brings India 3/4 of its annual rainfall. Means about 73-74% of India's average rainfall of 1 year, that is from these winds only. And this moisture comes to India in just 4 months. Now, when I say India gets precipitation, moisture from these winds, don't think it's a clear point that moisture of the Indian Ocean is being transferred to India. So during June to September, when it rains in Delhi, which moisture we people in Delhi will get? The moisture of the Indian Ocean, which is brought by the winds called southwest monsoonal winds. So every one of us understands, not only for India, for the whole world, the rule is that most of the precipitation we get on the continents, we owe it to the oceans of the world. Yes or no? Means I'm not saying entire moisture we get on the continents through precipitation is from oceans, but most of it is from oceans, because we have water bodies on the continents also. So when you understand this point, that most of the precipitation we get on the continents, we owe it to the oceans of the world, it means you are agreeing to my point that moisture travels from one place to the other. Yes, please. For example, for we Indians, moisture travels from Indian Ocean to different parts of India from June to September. Now, if you agree with this, that moisture travels, then you have to agree with me that when moisture travels, heat also travels. Because you have done in school science a concept called latent heat. What is latent heat? The hidden heat, which is either absorbed or released when there's a transition of one substance from one state to the other. So please see here, water, liquid, turns into gas vapor. We say air holds moisture in it. Now, can I say air holds moisture in vapor form? And you know, when liquid becomes vapor, in this process we have done in school science, latent heat is absorbed. Now, this expression which I have written on the board is very simple, but you will see in the classes of atmospheric science and oceanography that this statement is very crucial for making us understand our nature. What is the learning you take home from this simple expression? That every molecule of vapor in air around us is now a source of energy in itself. Is this vapor is holding latent heat. And whenever with this vapor will change itself into water droplets or into ice crystals. You have seen clouds. What are clouds? Clouds are the result of condensation and or sublimation. It means when you see a cloud up in the atmosphere, it is the manifestation of vapor getting converted into water droplets or ice crystals, solid ice crystals. So, when this vapor will change into water droplets or ice crystals in a cloud, it releases latent heat. It means in the coming days we'll understand what is cloud formation. Remember, this is not the topic of the day. I'm just trying to show you that heat and moisture travel, okay? So don't misunderstand, teacher has taught clouds today, right? I'm just going for some reflections. That vapor gas, when it converts into water droplets, means liquid. This is one manifestation of cloud. What is the other? And or vapor may change itself into ice crystal, solid. These two arrows represent clouds. So when you see a cloud up in the atmosphere, you must think of this, that at that height in the atmosphere, vapor has changed itself into lots of water droplets and or ice crystal. This is what science calls as condensation. And this is called sublimation. Remember, traditionally, science uses the word sublimation for gas to solid or solid to gas. But some of you may know that gas to solid is also called deposition. But deposition is less popular, so we use the word sublimation. Okay. So, what is cloud formation? It is the manifestation of condensation and or sublimation. Now, when do we get water droplets? When do we get ice crystals? We'll see in the coming lectures. It depends on a special temperature called dew point. When dew point is more than 0 degrees centigrade, we'll get water droplets. And when dew point is less than 0 degrees centigrade, we get solid ice crystals. But I'm not interested in the detail here, because this would be one chapter separately. I want you to understand that in this conversion, latent heat is released. Okay. Now, so think of this in India. What is happening during summer season in Indian Ocean? Sun gives heat to the waters of the Indian Ocean. And what happens in this? The heat of the sun changes water into vapor. Now, this vapor is a source of energy. It is holding the sun's heat. So, what is India's monsoon? India's monsoon is a system of winds which collects all this vapor and brings it to different parts of India. When this moisture-laden air comes to Delhi, it would for some reason rise and will convert into cloud. And when it will make cloud over Delhi, there will be release of latent heat. So now the heat which is being released over North India during summer season, that heat which is being released over North India during summer season, was that heat given by the sun to North India or was that given to Indian Ocean? It was given to Indian Ocean. But what moisture-laden winds have done, what monsoon has done, it has collected all that heat in what form? In the form of vapor, and has transferred it to different parts of India. So tell me, is this example of India justifies my observation that in our nature, heat and moisture are the two major elements to describe the state of the atmosphere. But what is important for a science student to understand is that these two travel, and those motions are very important for our earth to become what it is. Okay. Remember, it was not the topic of cloud and precipitation, but just to make you understand better, I went for the concept of latent heat, etc. So is everyone convinced with this observation that weather and climate are described by two major elements, heat and moisture? And further, you need to know that they travel from one place of the world to another. Now, one more point, and this is known to most of you, that in school you have learned weather is a term to be used for the state of the atmosphere at a particular place, at a particular time. Means for a short duration, for a small area of the world, we use the term weather. and when you take the aggregation of the atmospheric conditions over a large area, over a long period of time, how much long? Generally we say 30 years or more. Then it is called climate. Okay. So climatic conditions are the aggregation, and weather pertains to a place and particular time. This is what everyone knows from school days. So using what all I have done in the last 5 minutes, let's write one sentence definition for weather and climate. Okay. Now there is a student asking me today that, sir, can you tell us something about El Nino? Now see, again, do give me some time, no? I'm teaching El Nino to my other batches which joined last year. So I believe that you need to wait for it, no? I'm very happy that you have such curiosity now. With the just one statement on the board, now you think of El Nino, La Nina, polar vortex and all that. I'm very happy. But I always tell my students, where was this curiosity last 15 years? If you have been so patient about learning for so long, have little patience in these classes also. So please write a sentence on weather and climate. Please write the term weather refers to the short run atmospheric conditions, involving heat, moisture and their motions, for a given time, and a specific area. Now write similarly the term climate. Please write the term climate refers to aggregation of atmospheric conditions, involving heat, moisture and their motions. Again the same, involving heat, moisture and their motions, over a long period of time, and for a larger area. And generally, how much time we take? It is 30 years or more. Okay. We'll see these things in the coming classes. So I repeat, over a long period of time and for a larger area. Now, I believe that you all will agree that you have understood the differentiation between climate and weather. Yes, please. Now, though you say yes, but I know with my little experience that many of you may still not know one practical difference between the two terms. It means on the face of it, you may agree that you have understood the difference, but there is something little practical which I need to make further more clear. Now see, though bookish definition is understood that one is for small area and a short duration of time, and the other is an aggregation for a large area for a long period of time. But I want you to understand little practically that though we talk about climates of the world, though there are books on climate, but you must understand that there is nothing real about climate. Means you must also understand that what is real out of the two is weather only. Now, why do I say this, that climates are not real? Because remember, at every moment outside in life, in nature, we experience what? Every moment we have weather. And what is climate? Climate is just a mental construct. That whatever I have experienced over a long period of time, I take the average of it and I call it as climate. It means it's something like, those who are not getting my point. Let's suppose I have lived in Delhi for 40 years now, and I have a friend in Paris who wants to come to visit me here in Delhi, and he is coming for the first time, and he writes to me that, let me know about the state of the atmosphere in Delhi so that I come prepared with. Now, what would I do? I would write to him on half a page the average, the summary shot of my experience of 40 years for different months of the year or not? Yes, please. So my experience of 40 years is what? Weather of Delhi. But what I write to him as a summary shot is climate. So what is climate? What is real? Real is weather. Climate is just a summary shot of my real experience. So we need to understand our subject in a practical way also. So to make this point more clear, I will now quote one person whom most of you know. You must have heard of Mark Twain. Yes, please. He is known for very good statements on everyday's walk of life. And he made one statement on weather and climate also. And to me, that one single statement is better than a chapter of the book of climatology. Now let's see what did he say on weather and climate. Listen to this carefully. He said, climate is what you expect. Weather is what you get. Now write this and feel it. You'll understand the subject in a different way. So write a statement by Mark Twain. Climate is what you expect. Climate is what you expect. Put a semicolon. Weather is what you get. This is a statement by Mark Twain. Now tell me, does it give you a different idea about the concept or not? Now, since I've quoted Mark Twain here, and since today's lecture is all about preparing you for future classes, so let me tell you one personal experience of mine. I'll not take much time, just 5 minutes. And that will also perhaps throw some light on this same point. See, in one of the summer vacations in Delhi, I took my family to Shimla. And we went there by train. And you know, train journey takes a number of hours. And in that train journey, I talked a lot about Shimla to my family members. Perhaps I got the time to impress my family members with little geographical knowledge which I have. And I spoke a lot, I remember. And later I had to repent a lot. Because what happened was, in that journey from Delhi to Shimla, I spoke a lot about Shimla. But unfortunately, when we landed there at the railway station, the conditions of atmosphere outside were extremely bad. So bad that we could not venture out of the railway station. Heavy precipitation, high wind velocity, and the railway staff advised us that you cancel your bookings and take a return ticket back. And we had to do that. We got all bookings cancelled because conditions are not to be good for the next 2 or 3 days. And when I was waiting with my family for return journey on the platform, I found my wife was looking at me with a question mark on her face. She didn't ask me anything, but as a teacher, I could read that question. Question was crystal clear, that she was trying to ask me what kind of geography teacher you are. because she was not able to correlate what he has been telling us on the way and what is there outside in Shimla. Then without her asking me, I had to tell her using Mark Twain's statement that what I told you on the way was climate of Shimla. What you're getting outside is weather of Shimla. And that day, I also made a statement. I told my wife further that it is a climate that attracts you to an area, and it is the weather which may force you out of that area. So write this statement also. Please write. It is a climate that attracts people. It is a climate that attracts people. Put a comment, right? And the weather that makes them leave. It is a climate that attracts people. And put a comment, right? And the weather that makes them leave. Yes, please. Is this understood now? So this is the way we learn subject of geography, okay? But before I go to the next point, let me tell you that I have never been to Shimla. That was just a story, my trick, to have everyone's focused attention on the board. So I keep playing these tricks, but next time the trick would be something else, no? Because when a teacher says, let me tell you what personal experience, everyone focuses, right? Okay. I have not been to Shimla, no? This was just by way of teaching you what is weather and climate. Okay. Now, with this background, let us learn about what school books give us about those three zones. So remember in the first lecture, we said Greeks were the first geographers of the world. And you know, at the time of Greeks, knowledge of the world was limited. So based on that limited knowledge, Greek scholars divided the whole world just into three climatic zones. And that is what school books give us as torrid zone, etc. So please write the title, Greeks. And against that you write, they gave us what? Three climatic zones. Now just give me 2 minutes on the board. Let's see this division. If you remember in the previous lecture, we said that whenever you need a broad division of the earth, then you can see the earth in three parts. Remember, tropical region, temperate region, and polar region, or lower latitudes, middle latitudes, and high latitude. So today we are going to discuss very briefly just the terminologies about the division of the world by the Greeks on the basis of climate. And they went for threefold division. So let's again take roughly the same parallels. This is your 23.5 degrees north. This is 66.5 degrees north. And this is your North Pole. And similarly in the southern hemisphere. You can copy this with me. 66.5 degrees south and South Pole here. So see, Greeks divided the whole world into three parts, three climatic zones. Now, this is not that important a division, because when I say the whole world is divided into three climatic zones only, it means it's very broad. The reason was that at that time they didn't have much knowledge about the earth. And today we have more detailed knowledge of different areas of the world. But in the very beginning of the classes, we should know about something which is indirectly related to this division. Your school books will not go into that investigation, but in my coming classes, we'll be focusing light on that. So I want to just put a small point for my future classes through this discussion. See here. And one rule we make in the classes today. If I speak in any lecture of geography about Northern Hemisphere, and if I do not say anything about the Southern Hemisphere, do remember the same goes true for Southern Hemisphere. It means from here onward, the rule will be broad patterns of nature would be same in both the hemispheres. But when we come to details, details certainly would vary. Because you know, Northern Hemisphere is a mix of land and water, whereas 80% of the surface in the southern hemisphere is water. So details would always matter or differ, but till the time I'm not going for details, the broad picture would be same. So mostly what will happen is my focus while teaching would be on northern hemisphere. And if I do not say anything on the southern hemisphere, you will take the same way. If I have to say something special, I'll mention it. Okay. So same rule applies now. Now, where were Greeks? Greeks were in Europe. So these Greek scholars, with their observations, they found that areas which are south of them, it means they're referring to lower latitudes of the previous lecture. They found they are very hot areas of the world. So climatically speaking, they call the tropical belt of the world, the lower latitudes, as torrid zone. So please write this, torrid zone. And it goes the same way for the southern hemisphere also, no? So under 3 climatic zones, first zone is torrid zone. Now in English, torrid would mean very hot conditions, means areas with very hot conditions. Or you can write hot conditions. Whatever one do you feel to, very hot or hot, means physical conditions. So areas with very hot conditions. And which belt are they referring to? Lower latitudes or tropical zone. So they are referring to tropical region, or we can say lower latitudes. Now, Greeks were in Europe here. They found with their observations that areas which are north of them, they are very cold areas of the world. So for this area of the world, in both the hemisphere, they use the term frigid. So that they said this is the frigid zone of the world. So second zone was frigid zone. By frigid zone, they would mean areas with very cold conditions. Areas with very cold conditions. And which areas they are referring as very cold? The polar region of our previous lecture, polar region, or you can say higher latitudes. Means we are using threefold division of the earth, higher latitudes. Now we come to the last point. Now see here, Greeks were living in the European region. They thought that we are in the best part of the world, neither very hot nor very cold. And they called their own area as a temperate zone. So the term temperate we have used in our previous lecture, that was originally given by Greeks for the sake of climatic division. So please write the third, temperate zone. Now there is a student in the class who is chewing a gum. My request is that please do not chew any gum in the class. Go out and throw it. I would not like to point out very clearly in my first lecture, in the initial lectures like this, okay? You're disturbing my attention. Because when you're eating something, if you're eating alone, it disturbs me. Okay? Temperate zone. So they use the term, yes please, temperate zone for their own areas. Now please tell me, if torrid is hot in English and frigid is very cold, what is the meaning, the first impression you get from the word temperate? Moderate, excellent, very good. So everyone would immediately say that it suggests moderate. So please write here, areas with moderate conditions. Now see, in your school books, this division of the earth is given only for the sake of three terminologies: torrid, frigid, and temperate. But my purpose is not that much, because if that was the only purpose, then I would have asked you to read this from the books, because this is so clear otherwise also. There's nothing technical for it. But my point is something deeper for my future classes, and that will emerge in the next few minutes. But before that, for that some reason which I'm going to discuss with you, please put the word moderate within inverted commas here. Means it needs some special discussion today for my future classes. And before that, which zone they are referring as temperate zone? Yes, please. Middle latitude. So right here, they are referring to middle latitudes. Now, so there is a threefold division of the earth on the basis of climates given by our Greek ancestors. And this is torrid zone, the frigid zone, and in between we have temperate zone. Now, this is what is given in school books. Now, before I go for something important for my future classes for which I discuss it, let me just give you one hint, which is not my subject matter, but for your reading of NCERTs, you may get some benefit out of that brief discussion. See here. Geography as a subject deals primarily with this man-nature interactions. Means geography is a unique subject in this sense that we deal with man, we deal with nature, and we deal with interactions between the two. There are not many subjects in our society today where we deal with both human elements and the nature together. We do it in geography, and we do one more further step, that is interactions also. So man-nature interaction has been the prime focus area of geography. And as a result of this focus, there are different schools of thought which have emerged to deal with this interaction. By different schools of thought, I mean the different opinions on this interaction. As I said, this is not my subject area because I have to teach you atmospheric science and oceanography. But for one reason of the reading of your school books, I say that broadly speaking, there have been two schools. One school which gives primacy to nature. Means in this interaction, that school says nature is supreme. Nature decides everything, and man has to follow what nature decides. And this school which gives primacy to nature, which takes man as a passive agent, has been called in geography as environmental determinism. Means environment decides everything. Man is a passive agent. Whereas the other school, there are many schools, remember we are talking about broad two divisions. The other school starts with man and says, yes, nature is important, but man is also an active agent. Man is not passive. They say nature is important, no doubt about it, but man is not a passive agent. And they say nature gives us many possibilities, and man as the master chooses what is best for the mankind. And this school which gives importance to nature but takes man as an active agent has been called a school of possibilism. Now let's go back to Greeks. Greeks were in the very early time when technologies were less. So suddenly Greeks by nature had to be what? Environmental determinists. Means that in their times nature was really more dominant. And how do these people justify the importance of nature? They say life in a desert is different from life in plain area, and that is different from coastal location. Whereas the school of possibilism will justify that no two deserts will have same life. Yes or no? Somewhere man has taken the role of technology to change the life even in a desert. So there are different arguments of these schools, and there are many variants of these schools we teach at higher level geography classes. And who were Greeks? Greeks were environmental determinists. And since they were in early times, some of them were very extreme determinists. And they went to extreme kind of an approach. And they said People like, see, I mean, I'm just giving you a small observation, but now you will hate these Europeans with this statement. These Greeks said people who live in the torrid zone, means where they were referring to we Asians. They said because of heat and humidity, they would be lethargic. And they are destined to be the slaves of the world. Imagine. Means right from the beginning, they have the same intentions. So they said, Asians are bound to be slaves in the world. They are destined to be slaves because of heat and humidity. They will not be able to work. They would be lethargic. And they said people who live in the frigid zone, because of extreme climatic conditions, they will never be able to politically organize themselves. And they will never be a political force. And they said, we are in the best part of the world. And we are destined to be the rulers of the world. Now, let us not accept their views for Asians. And these people in the high latitudes will not accept their views about their own location. But did you notice that these people, Europeans, they did emerge as rulers of the world? So it means there is something in this area which really favored them. So as you read your NCERT books for geography and then ecology you cover in these classes here, you will get to know in many different ways that these middle latitudes do have clearly a set of natural advantages. For example, we suffer with heat and humidity in extreme, but they have cooler conditions, better conditions. We need for more efficiency AC. They perhaps do not need. Means they have colder conditions in general. Many things have shelf life which is much longer. And when you look at their forests, they have advantage. They have both the types of forests, hardwood as well as softwood. Softwood is very important for paper industry. And hardwood which they have is better than our hardwood. Their hardwood is lighter in weight, stronger and more durable. And when you look at their grasslands, they are more beautiful. Their grasses are more nutritious. And animals, when they eat those grasses, those animals are less in number, but they are highly productive. And they have been good in milk industry and all related things, chocolates and all other things they have been producing. So they have many clear advantages over the other parts of the world. And if I was to sum up world history in 1 or 2 sentences, I'll not be wrong if I say that these Europeans coupled their natural advantages with technology, and that gave them the Industrial Revolution. And they coupled their Industrial Revolution with the supremacy in the world waters, the oceans, and that made them the traders of the world. And can I say, rest is world history. Means your history, if you don't tell the history teacher, they waste a lot of time. They tell you history in so many lectures, but history is this only. That today's political map is the result of this process. Yes or no? Means those relationships are still true, what they have taken out of this particular broad generalizations as such. Now, this is one part. But my intention was not this. My focus is for something else. Let us learn about this area of the world from my subject point of view, that atmospheric science. Please see here. In the coming days, you will understand that these middle latitudes of the world experience the highest variability of weather. Think of this point. Remember, weather by definition will change everywhere. What is the definition of weather? State of the atmosphere at a particular place and particular time. So it is bound to change. The moment you change the place, the weather will change. The moment you change the time from a particular at a particular place, weather will change. Means when you woke up in the morning today in this area, you had one state of the atmosphere, and by afternoon it was very different, and the evening it is further more different. So weather by definition is bound to change. But in the coming days, you'll understand that the middle latitudes are the areas of the world where we experience highest variability of weather. And let me illustrate this little practically, because today's lecture is for orientation of the future classes. So let me show you with some practical observations that how much variability we have in this area of weather. First, first illustration is when two Britishers meet, their first talk is about weather. Means there's a saying in Europe that when two Britishers meet, their first talk is what? Weather. Means unlike we Indians, they don't talk about others. You know, when we Indians meet, we talk about someone else, our common friend or common relative, no? But Britishers don't do that. Why? And what exactly they discuss in the very first meeting, the first moments of the meeting, they talk about weather conditions. Why? Weather is always a matter of interest to them. Why? Because weather keeps changing. It changes so much that weather is always a matter of interest in Europe. In particular, I said for Britishers. So that tells you that this is really a zone of high variability. Second example, when you watch TV serials and movies from this area of the world, you would have seen very often that when the actors who are involved in that, when they leave their places in the morning, they might be wearing a t-shirt or a shirt, but they carry leather jackets on their arms because they have a fear that they might have colder conditions on the way. And we Indians, we are so confident that we pack our woolen clothes in big trunks, and that too for months together. Does it happen or not? It means in our areas, weather does change, but not so much. Means in a comparison way, I'll say there's almost a constancy of weather conditions in tropical areas if I was to compare with this variability which Europeans or middle latitudes in general have. That they need to have all the things ready all the time, because they never know when there would be sunshine and then there would be rainy conditions, or it might get that there may be snow also. So when you go to a place like Scotland or some other places, you'll find people when they move out of their places in their cars, they will have everything for the day. The third example, when you watch cricket matches being played in England, has it not happened that match gets interrupted many a times? When there is one moment there was a sunshine, and then you went out for a cup of tea, and when you came back, you find match has been stopped because now the news is that it is raining there. You switch off the TV with the understanding that now there is no point sitting at home, and you go to a friend's house at a distance of 30 minutes, and you find your friend is watching the same match again. It means conditions keep changing from sunshine to rainy and all that very fast. And let me surprise you further, and this will be understood in the coming days. In your ecology and geographical details, either from books or from classes, you'll get to know there are certain locations in this belt where in just 24 hours, you may experience what other areas of the world experience in 1 year. Means the 4 seasons of the year might be experienced in just 1 day. It is that kind of variability we have in this area in certain pockets. Now, if you are really convinced about it, that this area has very high variability of weather conditions. Now, let us go back to what Greeks have done. Now, let us for a moment erase this part of the lecture. Let's suppose I have not given you about this variability. Now tell me honestly, if this variability was not told to you, would you get this interpretation from the word temperate? Don't you think the word temperate is a misnomer? If you are not told about this variability, the word temperate will never give you the idea that this area has such a great variability of weather condition. In fact, the term temperate is leading you to a different direction. So what is the conclusion I'm trying to reach at? I want to convince my class today that our ancestors, Greeks, made a mistake by using the term temperate for that area of the world which has such a great variability. So we conclude that the word temperate is a misnomer for the middle latitude. Now just wait, I'll make it right. So it means what is technically understood today? That since word temperate is not correct for the kind of conditions this area has, so we should avoid using the term temperate, and whenever this area is to be discussed about, we should simply call it as middle latitudes. because middle latitudes is a neutral term. It doesn't tell us about the weather conditions. So we'll have right perspective to deal with whenever we come to talk about this area. Now, there's one more interesting observation that we all understand now, that the word temperate is a misnomer. We should not use it. But you will find in all classes of geography and ecology and all books of geography and ecology used worldwide, the term temperate is still very popular. Means there would be instances like this. An author would write in the first chapter that the word temperate is wrong. But in the rest of the chapters, the author himself would use the same term. So it means a question maybe in someone's mind that when we know it is wrong, why are we using it? Then one author has written beautifully. He says, we all know it's wrong, but we are still using it, perhaps only for the reason that our ancestors sitting up in heavens should not get annoyed about it. Means he says that there's no reason for us to use it, but just to make the Greeks happy, they're up in the heavens, we are still using it. So please write one sentence on this. Please write. The use of the term temperate, is a misnomer, for middle latitudes, as these areas have the highest variability or maximum variability of weather conditions of the world. As these areas have the maximum variability of weather conditions of the world. Maximum variability of weather conditions of the world. Okay. Now, some students will have a question in the mind that, sir, what is the reason for this variability? Yes, do you have this question? Then my first response would be that this is what you will be taught in the coming lectures. Okay. But if anyone wants to understand broadly, let me just throw some points which will be understood technically in the coming days. Okay. But today I'll just give an idea, because this area of the world is going to be very important for our atmospheric science classes. So let me just give you a broad idea, but remember, details will come in the technically sequential way. Please see here. After a few classes, we'll be discussing air circulation of the world. And you know, air will move because of differences of pressure of the atmosphere. Our atmosphere exerts differential pressure on the earth surface. Some areas have higher pressure, some areas have lower pressure. And air will always move horizontally from higher pressure to lower pressure. Higher pressure for today's lecture means more air acting over me. Less pressure means less air acting over me. It means nature will send the air from high to low. It means wind, which is the horizontal movement of air, would be nature's attempt to balance the unevenness of pressure. Now, in the coming days, we'll decide technically which areas of the world have higher pressure and which areas have lower pressure. And you will see something like this will emerge. How and why? That is not the question today. In the coming days, we'll understand that near equator, we have low pressure. Near 30 degrees, on an average, we have high pressure. Near 60 degrees, we have low pressure. And near poles, we have high pressure. Why and how? That we'll see later. Now, since air moves horizontally from high to low pressure, so low pressure areas will become the areas of convergence of air. Means air will come out of the high pressure areas and will meet where? In the low pressure areas. The middle latitudes, low pressure areas would be very interesting areas for us. Because you notice that air which will meet in Europe, in the middle latitudes here, would be of contrasting nature. Means you will see in the coming days, air will come from the polar areas, which is cold air, and cold air is dry air. Remember, we will see whether very soon, air holds moisture in it, and warmer air holds more moisture. So cold air as a rule would be dry air, and the warm air which moves from the tropical areas would be warm and moist. So let us suppose I'm standing in Europe and this board is the polar region and your area is on the screen side, tropical areas. So my hands are the air masses. So you'll find in the middle latitudes of Europe, the tropical warm and moist air will meet with cold and dry polar air. And when the contrasting masses of air would meet, since they are unlike, they don't mix into each other. Norwegian scientists were studying this phenomenon for the first time at the time of First World War. So during First World War, Norwegians were studying this phenomenon. They found the two contrasting masses of air meet in their area and they are not mixing with each other. There's a zone of transition formed. And since it was the time of the war, they called this zone of transition as a front. So in middle latitudes, we have a very interesting phenomenon of the atmosphere called front. Front would be a zone of, I'll make you adjust it. Front is a zone of transition. And in the coming days, you'll understand that we have two types of cyclones in the world. Geographically speaking, cyclones would be tropical and extratropical. Extratropical means which happen outside the tropical belt. It means the ones which happen in temperate areas. And we'll say temperate cyclones are frontal in origin. It means first a front will form and some of these fronts will become temperate cyclones. And these temperate cyclones would become the major reason for causing variability of atmospheric conditions here. And we Indians know it very well. Have you heard of the term Western disturbance in India? So you will see that some of these temperate cyclones will visit our area of the world, where India, Afghanistan and Pakistan meet. And we Indians and Pakistanis will call those temperate cyclones which visit our area as Western, because they come from West. Disturbance would be a term technically used for something called as secondary circulation. Means for the time you understand, it's a term for cyclone and related things. So when this Western disturbance comes to India, many of you know that it becomes a reason for snowfall in Himachal Pradesh and Jammu and Kashmir. It becomes a reason for rain in winter season in Delhi, Punjab, Haryana, etc., which is good for Rabi crop wheat. And then it brings our temperature in North India to very low levels. Means there's a sudden cold wave in India, North India. Why? Because this is a frontal system. Frontal means it has two air masses, one polar and one tropical. When the frontal system comes to India, when the warm air mass will reach India, you know we are already so hot. Will not feel the warm air mass. But when the polar air mass will reach India, there will be a sudden drop in temperature. And sometimes we'll have hail also. Hail means solid precipitation. Stones of ice would be there. So it means wherever these disturbances go, wherever these cyclones go, they cause variability in the weather. So it means, what is the learning without details? That this area of the world is going to be very important for atmospheric science classes because they are the zones of fronts. Fronts become these reasons for temperate cyclones. And temperate cyclones are very frequent, but they're not destructive. Remember, our cyclones are less frequent, but they are very destructive. Whenever they happen, we get to know they have happened because they can kill thousands of people in one go in the coastal region. So the major reason for this area's variability is the kind of convergence they have. So just write on the margin somewhere the term front. I'll be using it again and again in my classes. So please write, the term front refers to a zone of transition. The term front refers to a zone of transition between two contrasting air masses, Put a hyphen and write cold, dry, polar air mass and warm, moist, tropical air mass. Cold, dry, polar air mass and the warm, moist, tropical air mass. If you wish, you can write one more sentence. Please write. The fronts are primarily associated with middle latitudes. Fronts are primarily associated with the middle latitudes. And some of these fronts result in temperate cyclones. And some of these fronts result in temperate cyclones. And some of these fronts result in temperate cyclones. And the right, and these cyclones form a major reason, if not the only reason. These cyclones form a major reason for the high variability of weather conditions. For high variability of weather conditions. Form a major reason for high variability of weather conditions experienced in middle latitudes. High variability of atmospheric conditions experienced in middle latitudes. So without details, you get to know about a concept called front, okay? And in the coming days, we'll have more clear understanding. Now, let's leave this particular discussion. As I told you that I'm preparing you for my future classes. So today, in the next 20 minutes time, I'll share with you one very important feature of our planet. Again, without details, because details would need some more lectures. And this feature which we discuss would be the heart of my whole course with you. Please write a title. Please write global heat imbalance. Global heat imbalance. Please keep your pen down for just 10-15 minutes. And after that, we'll write 1 or 2 lines on this. Something very simple, but very, very important for our entire course. Details will come later. Let's see a macro perspective approach here. Now, in this discussion, I'll be using 2 terms. One, you are already familiar. Insolation. We have done this. Incoming solar radiation. The second term I'll be using today is out radiation. You all know from school days that if my left hand is the earth, it receives energy from the sun, but then our earth, our solid earth, acts as a very good radiator also. Means our earth from the entire spherical surface out radiates its energy which it had taken from the sun. And in the coming days, you will understand our atmosphere is majorly heated not by the direct sunlight, but by Earth's out radiation. Means you have done in school science that the majority of the energy of the sun which comes to the earth, majority of it is in short wavelength range. And our gases of the atmosphere are not good in absorbing that. So there is not much of heating of our atmosphere by the direct sunlight. But sunlight heats the earth and earth out radiates that heat, that energy. And out radiation by the earth is largely in the form of long wavelengths. And our gases of the atmosphere are good in absorbing long wavelengths. So major part of heating of the Earth's atmosphere is by out radiation. All these details will come later. Today, I'm just using the term out radiation in a broader perspective. Now, scientists of the world who study these things, they have discovered that on our Earth, there's a great heat imbalance. What is that? They have found that between approximately 35 degrees north and 35 degrees south, in this area of the world, there is a surplus of heat. The reason being that in this area of the world, insolation is much more than out radiation. And from 35 degrees north to North Pole and from 35 degrees south to South Pole, in this area of the world, there is a deficit of heat. And same way here, there's a deficit of heat. The reason being, in this area of the world, out radiation is more than insolation. Means Earth outradiates more heat than what it receives. This imbalance which I've shown on the board is called as global heat imbalance. And now related to your previous discussion, I said most of what I'll teach you in my classes in atmosphere and the world ocean, every major circulation I teach you would have one common pursuit, and that would be to reduce this imbalance of the earth. It means we'll study water circulation in the ocean, we'll study air circulations of all kinds, but every circulation at the end of the day would have one pursuit: to transfer the heat from the surplus area to deficit area and bring the colder conditions to the warmer zone. That is why I stressed on this point in this discussion, that heat, moisture are two major elements, and more important is motion part, because whole course will relate to the movement only. So even if we have not done anything in detail, I still went for that throwing of that important point, that this is what you will see. Now there would be some students in my class who would have a question immediately that, sir, how come this area can lose more heat than what it receives? Do you have this question? My first response would be, just wait for 5 minutes, you will understand. Please, you will easily understand that it is very much possible. But if anyone wants the answer immediately, I'll give a crude analogy for some reason. Tell me, and see the words I'm using for some reason. Tell me, do we have some mechanisms in today's society whereby I can spend more than what I earn? Yes or no? Yes. Banks give me loan. There are many other such kind of schemes. Every day we get phone calls, no? That your house is too small. Does it look like the teacher from Vajinabravi? So why don't you purchase a bigger one, take a loan from us? And so many other such kind of things, all you know. So you all know we can spend more money today than what we earn, because there are certain mechanisms in our society. And same way, look at Indian planning. Throughout your economics classes of school and college, and here in this course, you will find that in India, for most of the time, revenue collection is less than the expenditures planned. Yes or no? Means we go for deficit planning, and still the governments of India promise achhe din aayenge, and we believe them aayenge. Yes or no? Now, how can the government of India run its operations if the revenue collection is less than the expenditures? Because RBI has mechanisms for ensuring this kind of process or deficit planning. Yes or no? So my submission is very simple. If there are mechanisms in human society for making us spend more than what we earn, then Mother Nature is far supreme. It means you are going to see my whole course is about mechanisms in the atmosphere and in the world ocean, which will make this possible. It means whatever we study in our course, you'll find those are nothing but the mechanisms of transferring the heat from the surplus areas to deficit areas and bringing cold conditions from the higher to lower latitudes. It means it's like bank loans and grants, no? That this area would be able to outradiate more because it's going to get transfers of energy. So my whole course is about what? The mechanisms both in the atmosphere and world ocean. Now remember, yes, nature has number of mechanisms for transferring heat from the surplus areas to the deficit areas. But at the end of the day, we also need to remember that even after these transfers, there is no uniform distribution of heat on the Earth's surface. Means at the end, we still know that lower latitudes are hot areas and the higher latitudes are cold areas of the world. Now, someone may have a question that, sir, why Mother Nature has not gone for a uniform distribution of heat when it was going for this transfer? Why does it not make it uniform? Then your ecology classes will answer this question, that if Earth would have been having a uniform distribution of heat, then life on the Earth would have been more uniform. And uniform life is not very strong, very resilient. So you will find diversity is nature's rule, because diversity makes the nature more resilient. Means the diversity of nature acts as a hedge, as a support for any emergency. So nature had a grand plan that by having variations in an amount of heat and hence in the moisture in the air, will have different kind of life forms. Thousands of species of flora and fauna would be there, and that diversity will make system stronger. So nature went for reducing this imbalance, but not eliminating this difference. And nature has done this reduction, because remember, if nature would not have gone for this transfer, then there would have been a problem, that the lower latitudes would have become with time hotter and hotter, and higher latitudes would have become ever colder, and then life would not have been possible on the Earth. So to make Earth a living planet, and that too with kind of diversity we have, nature went for reduction of this imbalance. And in the days to come, you will understand, whatever total heat transfer happens in nature, out of this heat transfer, approximately 80% of it is by the mechanisms of the atmosphere, and about 20% is by oceanic circulations. Now, I can't illustrate those processes today because they need, I can't teach you cyclones today or the wind systems in general to explain this heat transfer. But I can take 5 minutes to explain the heat transfer which I mentioned with the help of concept called ocean current. It will just take 5 minutes and you will understand. See, in the coming days, we'll be spending 2 classes on ocean currents. What is ocean current? If this board represents the depth of the ocean, we will be defining a term, surface layer of the ocean. By surface layer, we mean approximately first 100 meters of the ocean water. And we'll see that water in the surface layer of the ocean will move from one place to the other horizontally. And this horizontal movement of water in the surface layer is called ocean current. There was a 15 marks question this year's main exam on the causation of these currents. And 5-6 years back, the same question was there in this main exam. So horizontal movement of water in the surface layer is called as ocean current. And we'll divide these currents into 2 types, warm currents and cold currents. But the typology of cold and warm would not be based on any absolute temperature. The cold and warm currents would be in relation to the waters a current visits. Let's understand what I mean by this. Let us say this is area A and this is area B of the world ocean. And there's a current which takes water from A to B. Now, when the current takes water from A to B, if this water is warmer than the water which is already present there, then this current would be called as warm current. If this current carries water which is colder than the water which is already present there, this is cold current. Is okay? Remember, it's a very relative classification. That the current is warm or cold not on the basis of any fixed temperature. It is cold or warm in relation to water a current visits. Is okay? So can I say, if this rule is understood, can I say all currents which go from lower to higher latitudes would be warm currents, and currents which come from higher to lower latitudes would be cold current. So now you see these arrows as currents only. So the water of the lower latitudes is taken to higher latitudes. This would be what kind of current? Warm current. Now, does it not immediately tell you it is nothing but a mechanism for energy transfer? And cold water would be brought back from the higher to lower latitude. Means in just 5 minutes, you understand that all movements of the world ocean water are nothing but mechanism for reducing the heat imbalance. And that's what you will see in the cyclones of the world, the monsoons of the world, and all the wind systems of the world. So the whole course which I'm going to have with you on atmosphere and ocean would be about the mechanisms which are reducing the global heat imbalance, but not eliminating that. Okay. So please write these points in, means all what I've just said. Just make a rough sketch and then I'll give you the same observation. Just make a rough sketch. Yes, please write the diagram in words. Between approximately 35 degrees north and 35 degrees south, there is a surplus of energy. Yes. Between approximately 35 degrees north and 35 degrees south, there is a surplus of energy because insolation exceeds out radiation. Because incoming solar radiation exceeds out radiation. Because insolation exceeds out radiation. Second point. Polewards from 35 degrees north and 35 degrees south. Polewards from 35 degrees north and 30 degrees south, there is a deficit of energy. There is a deficit of energy because out radiation exceeds insolation. Because out radiation exceeds insolation. Because out radiation exceeds insolation. Full stop. Now write next point. Theoretically, such an imbalance, theoretically, comma, such an imbalance in energy distribution, such an imbalance in energy distribution could result in the lower latitudes becoming warmer, could result in lower latitudes becoming warmer and the higher latitudes becoming ever colder. And the higher latitudes becoming ever colder. Full stop. Further, right? In reality, next sentence, in reality, comma, however, again a comma, in reality, however, energy is transferred. In reality, however, energy is transferred from areas of surplus. In reality, however, energy is transferred from areas of surplus to areas of deficit. To areas of deficit. Full stop. Further, right? In the same point, next sentence. Nature has provided mechanisms nature has provided mechanisms put a comma, both in atmosphere and the world ocean, both in the atmosphere and the world ocean, which attempt moderating the global heat imbalance, Next point, broadly speaking, put a comma, it is estimated that about 80% of heat transfer is through atmospheric mechanisms. About 80% of heat transfer is through atmospheric mechanisms, and about 20% through oceanic mechanisms or circulations, you can write, and about 20% through oceanic circulations or mechanisms. Remember, it's a broad division. So it means the point being given today is indicating that in all classes you'll find one common pursuit of all processes of energy transfer, right? With this, I leave this discussion here. Now, from here onward, we'll start with some specific topic. So I'll make a beginning in the topic today, and it will be covered in the coming days, and that is concepts related to time. Remember, out of latitude and longitude relates primarily to the concept of time. So let's first go for dealing with longitude and time, and in the coming days we'll have more focus on latitude. So please write this title, longitude and time. Now see, under this topic, I'm going to teach you today local time. And if time permits, we'll go for standard time. And then we'll be able to have time zones of the world. And then I'll prepare you for what is called international dateline. Then we'll go for some practices like daylight saving time, etc. You might have heard of by some countries. So let's first go for the base concept on which everything else would be based, and that is local time. So write the title, local time. And please be on the board for 5 minutes and don't write a thing. We'll write the notes later. See here. There's a globe in my left hand. So I relate longitude and time. I say, as Earth completes one spin in a particular, like how much time in a time of 24 hours? So Earth completes one spin in 24 hours. So one spin means 360 degrees of longitude. And 360 degrees of longitude relate to time 24 hours. So I'm going to make a relationship of longitude with time. But what is this time, which I'm going to discuss today with this approach? This is local time. Now, as the term indicates, local time is the time of a particular place. Now, how do I fix time for a particular place? I fix it in relation to the position of the sun in the sky. Now, you know from your school day science that if we were to fix the time of a place like Karol Bagh with respect to sun's position, after the sunrise in the morning, I can keep an object on the road outside and I wait for that moment when the sun goes highest in the sky, and that I'll get to know with shortest shadow of that object. Means that will indicate that angle of the rays is higher, the maximum, and that would be the moment when the sun has reached highest. And that moment I can capture in my watch as 12 noon local time. I would have explained this earlier while giving the term meridian last time. Yes or no? Romans gave us a term meridian. By meridian, Romans meant 12 noon local time. That is moment of the day when the sun is highest in the sky. So you understand what is local time, the time of a particular place. Now we relate this particular point with the movement of the earth. So I bring two dimensions. One again, earth spins once in 24 hours. So I equate 360 degrees of longitude to 24 hours. When I simplify this, I'll get 1 degree of longitude, suggesting a time difference of 4 minutes. Is that okay for everyone? The two places which are separated by 1 degree of longitude, they would have a time difference of 4 minutes. But whenever you have difference of time, a particular place may be ahead of the other place or maybe behind. So I have to have an idea what will decide that, whether the place is ahead or behind of the other place. So I bring the direction part also. So I say earth rotates from west to east. So the place which is on the east will face the sun earlier than the place on the west. For example, Australians, New Zealanders or Japanese would face the sun earlier than we Indians. So they are ahead in time. So east you are ahead and west you are behind. So we Indians are behind Japanese and we Indians are ahead of Americans because earth rotates eastward. Now we used the term meridian last time. Meridian is a line joining North Pole with South Pole and it joins all the places which have the same longitude. So, you know, when there's a difference of longitude, we have time difference. So in a way we can say all places which are along a given meridian, they would have same local time. Yes, please. Because they have same relationship with the sun. So when you have same longitude and location, time is same, the local time. But when there's a difference, the rule will be a degree of longitude gives me difference of 4 minutes. East you are ahead and west you are behind. Now, in this topic, they can ask us a question, a numerical, that they may give you local time of a place and they may ask you to find out the local time of some other place. So let's say if there is a place A and local time of this place is given as TA and the question says when time at A is TA, find out the local time at some place B which is on the east of A. Then what do I need to know? I need to know the meridian of A, the longitude of A, and I need to know the meridian of B. Once the longitudinal difference is known to me, let us say it is X degrees of difference. The rule is clear. 1 degree stands for 4 minutes. So I'll argue that the time difference at a time difference of B and A would be indicated by X degrees multiplied by 4 minutes. Is that okay for everyone? And whatever minutes I'll get, I'll convert into hours and minutes. I know 1 hour would make or 60 minutes would make 1 hour. So whatever total number of minutes I get as a time difference between B and A, I'll convert it into hours and minutes. And since the class has understood earth rotates eastward, so the place B is ahead of place A. What does ahead means? It would mean that the time people are having at A now, it is already lived by the people at B because they had earlier sunrise. Yes, please. So since people at B have already lived the time, they are ahead. It means to find out the time at B, I'll have to add to the time at A the time difference. Yes, please. So rule becomes east you are ahead and you add the time difference. Is that okay for everyone? Because people at B have already lived the time what people are now living at A. So to know the time at B, I go for adding the time difference which I have calculated here to the time at A. Now let's see the opposite. If you are given in a question the time at A, and the question says find out the time at a place C, which is on the west of A. Again, you need to know the longitude of A and C. So let's say it is given to you. Now you will find out how much is the longitude difference of these two. Let's say it is y degrees. So time difference between A and C would be indicated by y degrees multiplied by 4. These many minutes. I'll convert this into hours and minutes. And since C is on the west of A, so means C is behind. It means people at C are yet to live the time what is being lived by the people at A. So it means they are behind. So to know the time at C, the rule will be time at C is equal to time at A minus the time difference. Okay. So west U subtract and east U add. Yes, please. Is that okay for everyone? So this is what I had to teach you on the concept of local time. I'll make you write these points and then we'll see whether you are clear about this calculation or not. We'll do two very simple numericals, and once done, then we'll go to the concept of standard time. So please write a few lines on local time. Please write, local time at a place is fixed. Local time at a place is fixed with reference to the path of the sun in the sky. Local time at a place is fixed with reference to the path of the sun in the sky. Full stop. Next point. It is 12 noon local time. It is 12 noon local time when the angle of inclination of the sun, when the angle of inclination of the sun, when the angle of inclination of the sun is maximum. When the angle of inclination of the sun is maximum. Within bracket, you can write that is the shortest shadow movement. That is the shortest shadow movement. Next point. All places on a given longitude, all places on a given longitude have the same local time. Have the same local time. Now someone wants me to repeat the first one, Bharti Yadav. So I repeat, local time at a place is fixed with reference to the path of the sun in the sky. That was the first sentence, right? Now write the next point. Earth completes one spin in 24 hours. Earth spins once in 24 hours. Then right, this implies, now please copy this. This implies 360 degrees of longitude is 24 hours is equal to 24 hours. Earth completes one spin in 24 hours. Then right, this implies 360 degrees of longitude equal 24 hours. Then right, further, this further implies a time difference of 4 minutes. This further implies a time difference of 4 minutes for 1 degree longitudinal difference. This further implies a time difference of 4 minutes for 1 degree longitudinal difference. For 1 degree longitudinal difference. Is it okay? Now write the next point about the direction. Please write. As Earth rotates from west to east, as Earth rotates from west to east, put a hyphen and write the rule. The time difference is to be added the time difference is to be added in the case of places. The time difference is to be added in the case of places to the east of a point. In the case of places to the east of a point. And it is to be subtracted. And it is to be subtracted for the places to the west. And it is to be subtracted for the places to the west. I repeat, the time difference is to be added in the case of places to the east of a point, and it is to be subtracted for the places on the west. Okay. Now, let us check our understanding of this numerical by very simple questions here. The first one is just one step calculation. Please write. Find out the local time at Tokyo. Find out the local time at Tokyo. Now, when you write Tokyo, write within bracket 140 degrees east longitude. So my question is, find out the local time at Tokyo when it is 12 noon Monday at Greenwich. When it is 12 noon Monday at Greenwich. When it is 12 noon Monday at Greenwich. Yes, please. This is just one step calculation. Give me the answer fast. Yes. Yes. Raise your hand. Where are you? 9:20 p.m. Monday. Do give a complete answer. No, Monday. It is for Monday. So right, 9:20 p.m. Very good. 9:20 p.m. Monday. This is just one small calculation. Everyone should get that same answer. Yes, please. Let's do it together on the class for the class as on the board. See here. You are given the time for Greenwich. What is the time given? 12 noon Monday. And you know Greenwich as our reference, it is 0 degree meridian. And the question is asked for, let's say Tokyo here. Tokyo's longitude is also given to us. It is 140 degrees east. So this is the difference. Since this is 0 and this is 140 degrees east, so difference is 140 degrees. So time difference between Greenwich and Tokyo is 140 into 4. How much is this? 560 minutes. Is okay? Now we need to convert these minutes into hours and minutes. Now there's a student Yash Agarwal, and there would be some more students in the class also here offline, that they will make a small mistake here, that to convert 560 minutes they will divide it by 60 and the answer will come as 9.33. But you need to have the right interpretation of it. Now better would be that you do this way, that you make hours out of these minutes. How many complete hours you can make? 9 hours. How much minutes would be consumed by making 9 hours? 540 minutes. So it means you have 9 hours and how much left? 20 minutes. So it means 560 minutes convert into 9 hours and 20 minutes. Now, if you go by calculation like Yash has done online, that you divide it by 60, nothing wrong with that. But your answer is 9.33. Then you need to know 0.33 means 1/3 of an hour. So it would mean 9 hours and 20 minutes. You don't add straight away that. So better is you do this way. So it means, what is the understanding now? Since my earth rotates eastward, so a Japanese in Tokyo is ahead of an English person at Greenwich by 9 hours and 20 minutes. It means the Japanese here has already lived the time what English person is living now. So I add this time difference. So when I add 9 hours to 12, it is 9 p.m. and I add 20 more minutes. So answer for Japanese would be 9:20 p.m. and day remains Monday. So this is the answer. It means since my earth rotates eastward, the day started earlier for Japanese So it means we understand that perhaps Japanese are on the dining table for dinner and English people are still not very clear with whom and where and what would they have for their lunch. Yes, sir, they are still looking for some partner and the place is also not decided. So they are still waiting for the lunch, no? Because Earth rotates west to east. Now let's write one more question and after that we'll shift to standard time. Please write, a cricket match commences at Delhi. A cricket match commences at Delhi. Now when you write Delhi, write within bracket, longitude is given to you, 77 degrees east. A cricket match commences at Delhi at 10 a.m. on Sunday. At 10 a.m. on Sunday. Now question says, what will be the local times? What will be the local times at Sydney? Now for Sydney you write 150 degrees longitude, east longitude and other places. So question is, what will be the local times at Sydney and New York? And New York City, you know, is on the west of Greenwich. It is 74 degrees west. What would be the local times at Sydney and New York when the radio commentary is received? When the radio commentary is received. So I repeat the whole question. A cricket match commences at Delhi at 10 a.m. on Sunday. Question is, what will be the local times at Sydney and New York when the radio commentary is received? For Sydney, the longitude is 150 degrees east. And for New York City, 74 degrees on the west of Greenwich. Please get me both the answers. One for Australians, the other for?
8 p.m. Sunday.
Yes?
8 p.m. Sunday, Sydney.
Very wrong.
2 p.m. 52 minutes, Sydney.
Yes, who said? 2:50? 2:52 p.m. Sunday. For Australians in Sydney. Very good. So answer, first answer is correct here. 2:52 p.m. Sunday for Sydney. Now do it for Americans on the west. Yes? For Americans? No, wrong. Yes, anyone who's done it for second, the case of New York? There is one student, Rajan, has done it correctly online. It is 11:56 a.m. Sorry, not, he's also wrong. Rajan is wrong, sorry. 11:56 p.m. Saturday. Answer is 11:56 p.m. Saturday. 4 minutes before midnight. Rajan has written 11:56 a.m. Saturday. No, it's p.m. Just 4 minutes before midnight. Yes? We have already decided the right answer and you are giving us wrong. Yes, please, let's do it together on the board. Yes, please be on the board now. Let's say this is Delhi. And it is located along 77 degrees east. Time for the match is as 10 a.m. Day is Sunday. Now question is for Sydney first. Sydney's longitude is given in the question as 150 degrees east. So you need to see this difference. So time difference would be 150 degrees minus 77 degrees and you multiply it by 4. How much is this answer? Yes, please. How many minutes? 92 minutes. So you convert this into hours and minutes. 4 hours would be consuming 240 minutes. You are left with 52 more minutes which are not making an hour. So it means the time difference is 4 hours and 52 minutes. Again, the same logic. Since Earth rotates eastward, Australians in Sydney are ahead of we Indians in Delhi by 4 hours and 52 more minutes. So we need to add, because Australians have already lived the time what we Indians are living in Delhi now. So we add 4 hours to 10 a.m. It is 12, then 2 p.m. and then 52. So it is 2:52 p.m. and day remains Sunday. Yes, please. Is that okay? Now I go to second part of the question, New York City. Here you have to just have a little caution. You are 77 degrees on the east of Greenwich and you have to go to New York City. So let's say this is 0 degree and 74 degrees on the west here. This is the location of New York City. So Delhi is 77 degrees on the east and New York is 74 degrees on the west of the Greenwich meridian. So it means this total difference you have to take. So total time difference would be, or total longitudinal difference is 74 degrees plus 77 degrees into 4. These many minutes. This calculation would be 604 minutes. When you convert this into hours and minutes, it would be 10 hours plus 4 minutes. So since my earth rotates eastward and Americans in New York City are on the west, they are behind. They are yet to live the time what we Indians are living in Delhi now. So I need to subtract. By subtraction, I mean I need to go back. Need to go behind. So I go back by 10 hours first. So from 10 a.m. I go back by 10 hours, I reach 12 midnight. Then I need to go back by 4 minutes further. So my answer is 4 minutes before midnight. 4 minutes before midnight would be 11:56 p.m. and day would turn to be Saturday. So we have started our Sunday already and Americans are still in the previous day. So at least in this way, Americans are behind us, if not in any other way, right? So this completes your local time concept. Now you write standard time. See, the problem will be now if I start standard time, I need a lot of time. Means to have a complete coverage, I need to speak continuously for about 45 minutes. Should I start? At least for the sake of courtesy, you said yes, sir, start. Even I'm not much interested. Yes, okay, then. Anyway, let me start. Yes? You have? I have to? Yes, you know it. Very good. Did I tell you in the very first class only? No, today I have to report to someone else also. On the way, I have to report to someone else, then I'll go to my madam. Now, okay, let me answer this question. There's a student, Sanjay, asking me, sir, how is time calculated at poles where meridian meets, or would meet? Now, first reaction to this question is, Sanjay, what is the purpose to go to the pole? Yes or no? A very practical question that, yes, you have all the reason to ask me a question, but what is the reason for us to go to the poles? So one point is clear that we have not much reasons to go to the poles. But if we are placed at the poles, then problem is the meridians are converging at the poles. So remember, we are there for a research work. So first, if I have to really deal with the time, I will go as per my purpose of research, that which nationality I belong to, or which particular other partners are there in the research. So there would be some concept of time given to us. Do you deal with? And second problem is that at the poles, we have 6 months of day and 6 months of night. The whole very concept of time would lose its significance the way we have understood. Okay. So very rightly, meridians converge at the poles, but the time would not be relevant the way we need it in other places. And if time is needed in the polar region, then we'll go as per the purpose of our research work or any reason we are there. Okay. Now, any other good question? Yes, please. Now there is a student asking me that, sir, time would be, don't talk. There's a student asking, Ravikant asking me that time would be slower at equator and faster at the polar region. We didn't say anything like this, no. Remember, in the coming days, we'll be studying about Earth's rotational speed. So rotational speed of the Earth will vary from equator to the poles. Earth will rotate fastest at the equator, and this speed will keep decreasing towards the poles. But remember, we are discussing not here the rotational speed. Our focus is on the angular speed, and the Earth's angular speed is uniform. So we make a rule: Earth spins once in 24 hours, and that happens the same for every place of the Earth. Means 15 degrees per hour is the angular speed of the Earth, which is uniform for every place. Means every place turns by how many degrees in one day? 360 degrees. So the angular speed of the Earth is same. 360 degrees divided by 24 hours. 15 degrees per hour. So since we are relating time with spin, so angular speed is important here, not the rotational speed. Rotational speed will vary from equator to the Earth. What is rotational speed? Rotational speed would be distance divided by time. So if this is my Earth, any place which is at the equator is to cover the longest distance for the completion of a spin. Time is 24 hours. But if there is a place here, it has to cover less distance, but the time is same. If this place is here, in the higher latitudes, distance is further reduced. So distance traveled divided by time taken is rotational speed. So as I move from equator to the poles, the distances to be traveled for the completion of a spin are decreasing, but the time taken is same for the spin, for the rotation. So what is happening is that rotational speed is maximum at the equator and it is decreasing towards the poles. And then I told you something today which will be very interesting later, that as I go towards the pole, Earth is getting reduced in size at a faster rate. So we'll see rotational speed of the Earth will decrease in a non-uniform way. And this would be a very important point in the coming days for what is called Coriolis effect. Have you heard of Coriolis effect? That our Earth's rotation will lead to some complex effect on the moving bodies like air, like water, like aeroplanes, like missiles and other such things which are moving from one place to the other. So there we'll have all these kind of considerations, right? Now, what I do is, because there is no point starting this because I need a lot of time to discuss. So next lecture will start with standard time. All the best, and just 1 minute. So I'll take leave from online students. Keep smiling, stay blessed, enjoy this process. Success will be very soon with you. Thank you.